All right, continuing the review for the Module 2 quiz. On this problem, it gives you a quadratic equation, x squared minus 4x minus 5, and then it shows you where the x-intercepts are on this graph. So you'll notice that the x-intercepts that you're seeing on the graph, there are two places where that parabola crosses the x-axis. The first one on the left crosses at -1, 0, and the other x-intercept is at 5, 0. Make sure that when you enter these into your answers, the part where it's asking for x-intercepts, make sure that you enter ordered pairs, not just numbers, but ordered pairs. Now, on the second part of this problem, it's asking you what the solutions are. Whoops. The solutions of that quadratic equation, x squared minus 4x minus 5, are going to be what the x coordinates were in those intercepts, -1 and 5. This part of the problem does not have parentheses. We are not talking about an ordered pair here. We are simply talking about the two answers to the quadratic equation. All right, on this next problem, it's talking about an extension ladder that is leaning up against a wall. And it says the foot of the extension ladder is 9 feet from the wall. Then the height that the ladder reaches on the wall and the length of the ladder are consecutive integers. How long is the ladder? Okay, so let's look at this. Drawn out. So we have a wall, there's the ground, and here's our ladder. Okay, so it tells me that the foot of the extension ladder, which is here, is 9 feet from the wall. So that side is going to be 9. Then it said that the height that the ladder reaches on the wall, which is this height here, and the length of the ladder are consecutive integers. What that means is one comes right after the other. So if we name the wall side as our x, then the ladder side, being the very next number, will be x plus 1. Now, we are going to set this up according to the Pythagorean theorem, because when you draw out this diagram or this picture, it gives you a right triangle, and all right triangles follow the rule of the Pythagorean theorem, that if you add together both of the sides squared, it's going to be equal to the hypotenuse, which is that ladder side, squared. So my left side of this equation, my first side will be the x. So I'll have x, and then I'll square it, plus the other side, which is this side, squared. So I have 9 squared is going to be the hypotenuse, which is the ladder side. So x plus 1 squared. Now, let's see what we have here. I've got x squared plus 9 squared is 81. And then I have x plus 1 squared. I'm going to write that out over here, because that means you are going to multiply x plus 1 times itself. So I'm going to distribute the x. X times x gives me x squared. Then my outer x times 1 gives me x. And then I'll distribute the 1 to both of those. So 1 times x gives me x, and then 1 times 1 is 1. I can put these two terms in the middle together. So now I've got x squared plus 2x's plus 1. So that's what this x plus 1 squared ends up being. X squared plus 2x plus 1. Now, you'll notice that you have x squareds on both sides of the equation, which means you can actually cancel them both out by subtracting x squared from both sides. Once you do that, you're going to have 81 on the left side and 2x plus 1 on the right. So now I just need to solve, for this x. So I'm going to get the x by itself by subtracting 1 from both sides. So now I have 80 equals 2x. And then if I divide both of those by 2, I get x equals 80 over 2, which is 40. So now I know that this side is 40. But remember what the question is asking. It says the length of the ladder. Well, that's this side, which will be 40 plus 1, or in other words, 41 feet. Okay. On this next problem, it gives me this quadratic function, parabola, on the graph, and it even tells me where the vertex is. So the vertex, it tells me, is at 2, -3. So make sure when you're typing in the vertex, you enter it as an ordered pair. So 2, -3. And once you know what the vertex is, that's actually going to answer the other two questions for you. Okay? Remember, the axis of symmetry is going to be a vertical line that goes straight through the vertex. And it's always going to be an equation. And the equation's always going to be x equals, and then it's just x equals whatever the x coordinate of the vertex was, which is 2. So the axis of symmetry, and make sure it says type in equation. You have to type in the whole equation. So x equals 2. And then the minimum or maximum value of the function is its y coordinate of the vertex. So this one has a minimum value of -3. Now, on this next problem, it's asking me the same questions, but it's not going to show me where the vertex is. I have to find it on my own. So my function is f of x equals x squared minus 8x plus 15. And I'm going to find the vertex. I'm going to use the opposite of b over 2a. And your a is in front of x squared, and your b is in front of x. What this is going to give me is the x coordinate of that ordered pair that is the vertex. So if my b is -8, the opposite of it is going to be +8 over 2 times my a, and my a is 1. So I've got 8 over 2, which gives me 4. So 4 is going to be the x coordinate of your vertex. Now, in order to find the y, I will replace the x's in the function with what I now know x is, which is 4. So I'm going to have 4 squared minus 8 times 4 plus 15. Whoops, didn't mean to do all that. Then I would put that in my calculator. So that would give me 16 minus 32 plus 15, which is negative 16 plus 15, which gives me negative 1. So the y-coordinate of the vertex is negative 1. Again, we're going to type that in as an ordered pair. So it's going to be at 4, negative 1. There, couldn't find the parenthesis. Now, find an equation for the axis of symmetry. Remember, your axis of symmetry is just going to be x equals, and then whatever that x coordinate is, make sure you type an equation. So x equals 4. And then the last part says determine whether the parabola has a maximum or a minimum and find its value. So the way that you're going to show that or find that is by looking at the A. If it is positive, that means the parabola opens up, and that means its vertex is at the minimum. So the parabola opens up, and it has a minimum of whatever that y-coordinate is, which was negative 1. And then you're going to graph it. Now, you're going to have to tell it what shape, so I know I'm going to do a parabola, and then you'll notice the instructions in the in the yellow rectangle say to graph the vertex first. Well, we found the vertex to be at 4, negative 1, so to the right 4 and down 1. Now you're going to plot any other point. Let me bring up my calculator. So I'm going to put my function in the y equals, so that way I can use the table function to find another point besides the vertex. So I'm just going to go to my y equals x squared minus 8x plus 15, and there's my graph. So you'll notice that that vertex is at 4, negative 1. That's the point that we've already put in. So now I need another point. So I'm just going to hit the second key and the table, and then I'm just going to choose any of these points that I want from the table. Okay, so I will choose the point that's highlighted now, which is 3, 0 for another point. So to the right 3, up and down 0, to graph the next point, and then save it. All right, this one will be similar. We have f of x equals negative x squared minus 4x minus 11. So we're going to find the vertex again. So the opposite of b over 2a. So my b is negative 4, so the opposite of it will be positive 4, over 2 times my a. This time my a is negative 1. So I've got 4 over negative 2, which gives me negative 2. So the x coordinate of the vertex will be negative 2. To find the y, I'm going to replace the x's in my function with that negative 2. Be careful here because you have the negative, and then you're replacing the x with negative 2 squared minus 4 times negative 2 minus 11. Whoops, we'll get on that add. So I'm just going to take this to my calculator and type it in like I see it. So negative, then open parentheses, negative 2, close that, and square it, minus 4, open parentheses, negative 2, close, minus 11, which gives me negative 7. So the y-coordinate of the vertex is at -7. So your vertex is at -2, -7. And again, enter that as an ordered pair. -2, -7. So my axis of symmetry will be x equals, and then you're just looking at the vertex again, looking at that x coordinate. So x equals -2. Type in the equation, the whole equation. And does this one have a minimum or a maximum? So again, we're looking at the a. This time my a is negative. What that does is it flips the parabola upside down, which means its vertex is a maximum. So we've got a maximum value of -7. So it has a maximum. And the maximum value, again, is just whatever the y-coordinate of that parabola is. So it's -7. And then we'll graph it. Tell it it's a parabola. And again, we're plotting the vertex first. So left 2, down 7. -2, -7. And again, we're going to need another point. So let's put this in our y equals. Put in your function, -x squared minus 4x minus 11. So there's my graph. Its vertex is at -2, -7, and you'll notice that it is flipped upside down, and I need another point. So I'm just going to go to second table and get another point. Let's see, there's that -2, -7. So -3, -8 would be another point that I could use. So left 3, down 8, and plot another point. All right, on this next problem, I've got the function f of x equals x squared minus 10x plus 24. And again, it's asking me for the vertex first. So I need the opposite of b over 2a. So if my b is -10, the opposite of it is +10. My a is 1, so I have 2 times 1 in the denominator. So I have 10 over 2, which gives me 5. So my vertex will have an x-coordinate of 5. To find the y, I'll replace the x's of my function with 5's. So I'm going to have 5 squared minus 10 times 5 plus 24. I'll put that in my calculator. So open, 5, close. I'll square that. Minus 10, open, 5, close. Oops, close, plus 24, which gives me -1. So my vertex will be at 5, -1. It's a vertex, so again, it's an ordered pair. Now, will my parabola open downward and have a maximum or upward and have a minimum? So remember where we find that. We look at my A. If it is positive, that means the parabola is going to open upward and have a minimum. Now, it doesn't ask me to graph on this problem, but I do think it's going to be much easier to answer the the rest of the questions if you can see what this would look like on the graph. So the vertex is to the right 5 and down 1. And it opens upward and has that minimum value of -1. Because remember, the value is going to be the y coordinate. Now, the next thing it's going to ask me is, what is the range? So the range is the y values of the function. What this picture tells me, and what the fact that -1 is the minimum value, is that my y's start at -1 and then go up from there. So from -1 to infinity. Now, infinities, when we're doing interval notation, infinities always have parentheses. And I actually want to include that -1 in the range. Since I want to include it, I need to put a bracket around that -1. So when you're entering, you just use the bracket from your keyboard, then -1, comma, infinity, and then just use the parenthesis from your keyboard. And the last question, or the last part of this, is asking where this function is doing two things, where it's increasing and where it's decreasing. So again, this is another good reason to why I like to have this written out. Because remember, you're going to read this graph like a book, from the left side to the right side. When I'm coming in from the left, here's where I'm going to run into the graph first, this left side. When I reach this, those are the numbers that are going down. So that's my decrease side until I reach the vertex. And then on the other side, it's going to increase. So when you're talking increase and decrease, everybody gets parentheses, and we're using the x coordinate of the point where it's changing the direction. So my increase is on the right side of that parabola. So it's going to start at 5 and go forever to the right to infinity. The decrease side is the left side of the parabola, and it starts all the way on the left side of the graph at -infinity until it reaches +5. So increasing intervals, the increase was from 5 to infinity, and the decrease was -infinity to 5.